That song was actually called, let me get rid of this. Sorry. That song was actually called Paper Stack. And that little bit of the song that you heard, that's pretty much it. It's 3.5 minutes of that. Anyway, I picked it because today's little problem that we're going to write a computer program for is about a stack of paper. And you know, again, this is just kind of like for fun, and let's just do it and knock it out. You can follow the steps that I do in the video and turn it in, or just save it and you're done. All right, so pretend with me here. There's a line of people. There are 32 of them in line, 32 people standing in a line. They're all holding some paper. They're going to walk up to a certain spot, lay their paper down, and just put it in a stack. The stack's going to get bigger and bigger as each person walks by and lays down their paper. Visualize that with me here. The first person is carrying 2 sheets of paper, 2 sheets, and they lay it down. The second person puts down twice as much. That's 4 sheets of paper. Did that math all by myself. The third person puts down twice as much. That's 8 sheets of paper. So the amount of paper is going to double every time for every person. And so every person is going to walk up with their paper and put it on the stack and just put it on the same stack. The stack's going to get bigger and bigger and bigger. We are going to say that each sheet of paper is 0.076 millimeters thick. And the question we're going to answer is, how high will this stack be when everybody's walked by? It's 32 people. The paper doubles every time. It starts with 2 and it doubles every time. And so how high will it be when it's all done? So what, again, kind of like yesterday with the allowance thing, what do you think? 10 feet high? 20 feet high? 30, 50? Let's find out. All right. Again, I've got steps on the handout here written in English, but I'm going to show you exactly how to do it here in the movie. So I'm going to hop over to code.org. We are going to start this off by creating 3 variables. So I'm going to go 1, 2, 3. Remember, when you're declaring a variable, you have to use that var command. All right, first variable is going to be, I'm just going to call it person, and we're going to give each person kind of a number, right? You got person number 1, person number 2, person number 3. So we'll start this off with person equals 1, because that's going to be the first person in the line. The next variable, I'm going to call it sheets, and it's for the number of pieces of paper that person is holding, right? Person number 1 has 2 sheets of paper. So I'm going to make that equal to 2. All right, now the other variable we're going to need, this is kind of like the bank in the allowance program. The stack has to get bigger and bigger. Now, before that first person walks up and lays their paper down, the stack is going to be equal to 0. So we're going to start it at that. All right. Now we are going to need, and again, you could probably do it without this draw loop. You could get rid of the draw loop if you really wanted to, but I'll just leave it there. It doesn't matter. So I'm going to bring over my while. That's the kind of the key here. All right. So let's check out what we're going to do. What's the condition? How do we know when we're done? Think it through. Use logic. That's what computer programming is all about, is using logic. So use logic. How do we know when we're done? When the last person walks by. How many people are there? 32. So I'm going to do this. I'm going to say as long as person is less than 33. That's because I want to include 32. So I'm going to do it that way. There's probably other ways you could write it, but that's how I'm going to do it. All right. Now the first thing we have to do is, we're back to variables here, and this is not going to be the var command. Don't use the var command for this. Just use the x equals. We're going to start piling paper up here. All right, so the stack is going to have to get bigger. So the stack is going to be stack plus, which variable up there is telling me how many pieces of paper the first person's, it's sheets. So that's our little math problem. Stack equals stack plus sheets. All right, now I'm going to have a whole bunch of these console.log things coming, and they're going to have I'm going to use the plus blocks to put holes in them. So watch this. Work with, if you need to pause the video and then do this part, then do that. Whatever works for you. Here's what I'm going to do. this is going to say person, and notice that's in quotation marks. Anytime you put quotation marks around it, then that's exactly what's going to get printed in that console.log window, that debug window. Now, I want it to kind of keep track for me. So over here, this is the variable person. So this should be, say, like person 1, person 2, person 3, person 4. It should work like that. Okay, next thing I'm going to do here, I'm going to bring over a console.log. And I am going to want a plus block here. And in quotes, I'm going to say sheets in the stack. I'm going to leave a space there and close the quote. I could put a colon in there. Let's do that. Put a colon in there. All right. Sheets in the stack. You know what? I'm getting picky now. I want the colon back here by the K, and then a space, and then the quote. Okay, I'm going to do that. And what do I want to put here? Well, this is, I want it to show me how many pieces of paper are in the stack right now. All right, so I'll just put the variable stack right there. Okay, now that doesn't really tell us the thickness of how high the stack is. That just tells us how many pieces of paper it has in it. It doesn't tell me how high it is. All right, so let's do this. I'm going to bring over another console.log, and this is going to be, let's see, I'll bring over a plus block again. And in quotes, I'm going to say stack in millimeters, colon, space, quote. All right, so we're going to, I want to see a measurement of how high is this stack in millimeters. Well, okay. So that's going to be the number of sheets in the stack times, might have to look back at the handout here, you think? What was that number? How thick is a piece of paper? What did we say? 0.076. That's what we're going to use. We're going to go with that. All right, cool. So that should tell us how high it is in millimeters. But wait, there's more. Let's do this. All right, I'm going to do this. I'm going to say stack in meters, colon, space, or space quote. All right, now, this time, actually I might bring over one more plus block here, just for kicks and giggles. Nope, not a plus block. I'll just do it this way. How do you do meters? Millimeters to meters, right? So I'm just going to do this. I'm going to say stack times 0.076. That gives it to me in millimeters, but to change millimeters to meters, you divide by 1,000. And because of order of operations, I don't really have to have parentheses there or anything. It should work fine. Okay, when you click off of it, it's going to kind of rearrange that a little bit, but don't worry about it. It's okay. All right, now, sorry, one more little thing to spit out here as far as data goes. I'm going to have it do this. You see that? Stack in miles. What? Oh, you know what? Sorry. I do want a couple of holes in there. Now I can put it in there. Stack in miles, colon, space, quote. Now watch this calculation. That's going to be the number of pieces in the stack times 0.076. Okay, that's for millimeters. Divided by 1,000. That's for meters. Uh-oh. How do you go from meters to miles? Divided by 1609. Study that up. Look at that. That's kind of a long, weird-looking math thing, but trivia. That 1609, you know why, in track and field, usually at our track meets, they don't call it, oh, everybody line up for the mile. That's not what they call it. They call it the 1600, right? Well, that's because a a mile is just about, you see that right there, a mile is just about 1,600 meters. It's 1,609, so it's pretty close. All right, anywho, boom, there we go. Big old complex math thing there. Now, the only other thing I'm going to do as far as like reporting out here, I'm going to do, and I did this the other day, I'm just going to put a bunch of a dotted line. You could use a different symbol there if you wanted to, but all that's going to do is make it easier to read when we run this. Now, there are two other little calculation kinds of things we need to do, or this is not going to work. Okay, so here they are. We need to let's pop quiz. What happens to the number of sheets as each person goes by? Person number 1 had 2 sheets, the next person has 4. What just happened? All right, we got to do this. Sheets equals sheets times 2. Like I said, if you struggle with this stuff, just pause the video and just do that little part, and then come back to the video and see the next part. All right, and now, boom. Now, what happens to the person number every time? As a person walks by, person number 1 walks by, and now who's next? Person number 2. All right. So we better do this. Person equals person plus 1. If we don't do that, we're gonna crash out your browser tab because it's going to get stuck in an endless loop, and it's not going to be pretty. Whew. I think that's it. This should tell us how high the stack of paper is in millimeters, meters, and miles. Woo! All right. I'm going to pull up my debug console window here from the bottom, and I'm going to click run. And I'll wait a second, and boom, look down at the bottom of the screen. Are you looking at this? I can scroll this down here so I could get a report for every person if I wanted to, right? I've got person 1, person 2, person 3, person 4. But what we're really interested in is person 32. What? Stack in miles, 405.7? Yep. This stack of paper would be impossible. It'd be ridiculous. You can't even do it. If you have 32 people, and I feel bad for person number 32 because person number 32 is carrying like 200 miles worth of paper. Woo! I don't want to be them. So anyway, there it is. And this is another time where if you didn't get this answer, if your stack in miles was not 405.7 or your stack in meters should be 652,835, that's the right answer. So if you didn't get that, you should tweak around on your program, look back at the video, do whatever you got to do, but look around and see where it went wrong. We just used a while loop to calculate this stack of paper. Look at us go. And the other thing is this, folks, that's it. We're done. I'm not going to make an assignment for tomorrow. If there's anything you don't have finished up, you can work on finishing it up. I'll be in touch with you, not only just tomorrow, but not only just on Friday, but probably through the week next week. You'll get some emails from me, and I'll just touch base with you and just kind of wrap things up. But yeah, that's your last assignment. Woot. Fist bump. See you later.